So today we're going to review what we discussed before about PEMDAS, order of operations. We discussed this last year, but let's do a quick refresher. PEMDAS means parentheses exponents, multiplication division, addition subtraction. If you look at the MD and the AS in the acronym PEMDAS, I put arrows above the M and the D and arrows below the A and the S. And all that means is what? What does that mean?
That means the order. That means the order that you do addition and subtraction, and the order in what you will do multiplication and division, which is left to right.
Very good. So that means if I have a problem that has multiplication and division, I'm going to do it from left to right. And if I have one that has addition and subtraction, I'm going to do it from left to right. Very good. PEMDAS, or the order of operation, simply means the order in which you will solve the problem. Any questions on that?
No.
Okay. So now let's talk about the P. What does the P stand for?
The P stands for
parentheses. Excellent. When you're doing an algebraic expression or a problem in algebra, what else did you notice in equations besides a parentheses?
That exponent?
Other than parentheses.
Brackets.
Brackets. Excellent. So although you don't see a B here, parentheses, always think parentheses or brackets, parentheses or brackets, which means that's the first thing we're going to do. And then we have E for exponents. So we already know the MDAS. We've done lots of examples on that. Our focus today is going to be parentheses and brackets and exponents. Why do we have parentheses and brackets in the same algebraic problem or in the same problem?
Because
If you have a problem and you see parentheses and you see a bracket, why do they do that?
so you can know what to do first and to do second.
Very good. So that you know what to solve first and what to solve second. Wonderful. So let me go ahead and show an example of that. So let's look at the smaller problem. Now, when we're doing algebra, do we normally use the X for the multiplication sign?
No.
No. What do we normally use for multiplication?
We use a dot.
We use a dot. And you also can use parentheses or brackets. As long as that's next to a variable or a number, right? Yeah. It still means multiplication. So let's look at this first problem and let's solve it using what we know about PEMDAS. This is a simple one. We're not doing the exponents. We're just focusing on the simple PEMDAS formula. So what will we do first? We have 2 times 4 minus 3 divided by 3. What would you do first?
3 divided by 3.
Okay. Now you said we would do 3 divided by 3. Is that on the right side or the left side?
Oh, but you would do 2 times 4.
Very good. Remember, we multiply from left to right. So we would do 2 times 4, right? And that would give us?
And that would give us
2 times 4, 8. Okay, so let me go ahead and write that down for you. So I always say bring down your entire equation, right?
Yes.
Don't try to solve it in your head. I want to see all your steps. Bring down every single part. So 2 times 4 is 8. We brought down our subtraction sign. We brought down our 3, our division sign, and the 3, correct?
Yes.
Now, what do we do next? Thinking about PEMDAS.
3 divided by 3.
3 divided by 3, because that's division, right? We do multiplication and division from left to right. And what is 3 divided by 3?
3 divided.
So we have our 1. We have 8 minus 1, so this answer should be 7. Excellent. Now let's go to this problem here. 2 to the 3rd power, right? Times 4 minus, in parentheses, 10 divided by 5. Can you tell me what would you do first, thinking about PEMDAS?
I would have done...
Not I would have. You are going to do what? Bless you.
I'm 10 divided by 5.
Excellent, because that's parentheses. Yes. So what is 10 divided by 5?
10 divided by 5 is 2.
Excellent. And we bring our entire problem down. Yes. Okay. Now, you see how I put that 2 in parentheses? Did I really have to do that since there are no other numbers next to it?
No.
I didn't have to do that, right? Okay. Let's keep going. What would you do next?
The only time you would ever have to do that is that if there were no more signs left right there.
Right. So if there wasn't a sign between the 4 and the 2, then I would have to keep the parentheses because that means we would have to multiply. Correct. Thank you. So what's next? What do I do next?
The exponent.
The exponent. So what is that? 2 to the 3rd power is what?
2 to the 3rd power.
Think about what we talked about in our prior lesson. When I want you to show me all your steps, what is the phrase? What are you going to do to show me the steps?
Expanded notation.
Not expanded notation. Exponential notation. And what would you do for that to show me that?
2 times 2 times 2.
Excellent. And that answer is?
That answer is 6.
No.
8.
8. Let's write that down. Excellent job. What do I do next?
8 times 4.
Very good. And 8 times 4 is what?
32.
32. And we bring the entire problem down. Let's write that down. So 32 minus 2?
32 minus 2 is 30.
30. So our answer is
30.
30. Excellent job. Okay? So we talked about not scientific. We talked about exponential notation earlier, and now we are talking about the PEMDAS, order of operations, and how we can solve a problem that has parentheses, brackets, and exponents, and we can continue using PEMDAS to solve the problem. Any questions for me?
Nope.
Okay, I'm going to do another problem with parentheses and brackets and exponents, and I want you to talk me through how to solve that, okay? Let me write the problem down. So here are the problems. Don't get confused. Don't allow this to cause you any frustration. We're going to walk through it step by step, okay? So again, we're using PEMDAS. I threw in some parentheses. I threw in some brackets. I kept some exponents. And on the right side of the board here, I made a division problem. So this is just a division problem. Don't get, scared. It's very easy. Let's walk through it. Are you done writing the problem down? No? Write the first one down only. Yeah, don't write the second.
The longest one.
Yeah, don't write the second one down. And don't forget, please do not write in pen. I want your problems to be written in pencil. And then you can write the different steps as you go through in different color pen. I'm okay with that. But that initial problem, let's keep it in pencil. Just to make sure if you wrote it wrong, we can quickly erase. Okay, so let me know when you're ready.
Ready.
Okay, so what would you do first in this problem?
10 divided by,
we have parentheses and brackets, right?
Yeah, so the first thing you would do would be parentheses.
Very good. So let me say something. If you have a problem that has parentheses and brackets, you want to do parentheses first, brackets second. Say that. Parentheses first, brackets second. Excellent. So you said 10 divided by 2. What is 10 divided by 2?
10 divided by 2 is 5.
So I'm going to put that in there, and what we're going to do is rewrite the entire problem. So now that we have rewritten the entire problem, we now have to worry about our brackets. Do you have anything in the brackets that you need to solve?
Mm-hmm.
Okay. What do you have in the brackets?
You have exponent.
Very good.
Exponent, what you have to do first, and then that minus 5.
Very good. So we have an exponent, 3 squared, right? Mm-hmm. 3 squared. And I always like for you to expand it out through exponential notation to show me your steps. So how are you going to show me 3 squared?
2 times 2 times...
Nope, 3 squared. 3 squared.
3 times 3 times 3.
Very good. 3 times 3, right? 3 squared is 3 times 3. Remember, exponents is nothing more than repeated multiplication, right? And when you have a factor that's repeated over and over again, you can replace it with an exponent, right? So let's go ahead and do that. So now you see what I have there. We took our 3 squared. We wrote it down in exponential notation, which is 3 times 3. And you said 3 times 3 was what?
I said 3 times 3 was,
3 times 3 is what? 9. Excellent. So we have 9 minus 5. Is that correct?
Yes.
So go ahead.
9 minus 5 is 4.
Very good. So now everything that was in that parentheses and everything that was in that bracket boiled down to equal what number? 4. So now I'm going to rewrite the entire problem with that 4.
Yep.
Now, you see how within the brackets we had 3 squared and we solved that exponent. We could have solved the 4 cubed as well. How at the same time, however, you know, I like things to be done incrementally, step by step. So now that we have our 4 left in our bracket, what should we go ahead and solve? We did the brackets and not 4, 3. We don't call it 4, 3.
4 cubed.
Very good. 4 cubed. And you can also say X. There you go. You can say 4 to the 3rd power. Or you can say 4 cubed. Excellent. So we're going to write that 4 cubed. And what is it called?
4 to the...
No, but what are we going to write it out as?
4 times 3 times... No, 4 times 4 times 4.
And that's called what?
Exponent.
Exponential notation. Notation. So 4 times 4 times 4. So let's go ahead and write that and solve that for me as well. What is 4 times 4 times 4? So we solved 4 cubed to equal 64. Now, what are we going to do next? Rewrite our entire problem before we solve anything else. Let's go ahead and do that. And I went ahead and removed our bracket because we did not necessarily need it because we have signs on each side. Nothing is next to an integer or a variable, so we can keep going. So what do we do next? What else do you see in this problem that we have to solve?
7 times 3.
Excellent. 7 times 3. We did remember, Pemdas. We did parentheses in all the brackets. We did all the exponents. Now we're doing multiplication and division from left to right. Is there any division here? No, it's only multiplication. So what is 7 times 3?
21.
Excellent. So we're going to solve that. And then what are we going to do? Bring all our numbers down to rewrite our problem. Let's do that. So now we have 64 plus 4 plus 21. So we have a mixture of addition and subtraction in this problem. But you said no, we don't? Yes, we do. Very good. So now if you go back to PEMDAS, remember our order of operations, the order in which you will solve the problem, we have addition and subtraction. How do we solve addition and subtraction in a problem like this? We go from, look at the arrows, left, excellent, left to right. So let's do that. 64 plus 4 is 68, and 68 minus 21 is, very good, 47. And that's how we solved it. So what I'm going to do, I'm going to give you 5 minutes, not even 5, 3 minutes to solve the problem on the other side of the board, which is division, no biggie. And I will do it and you will do it. And then we're going to come back and see and compare our answers. One thing I want to remind you is that when you have a problem and you do not see parentheses, can we add parentheses?
Yes.
Yes, you can add parentheses. And when you're adding parentheses, it's going to just help you visualize how to solve the problem correctly. So go ahead and let's do that. So before you tell me your answer, let's go through the steps, and then you're going to tell me if you got the same thing. So the first thing I did was I put parentheses around my multiplication factors, the 2 and the 3. So 2 times 3 was 6. So I went ahead and rewrote the problem out to be 7 minus 6 plus 3 squared over 2 squared plus 1. Again, in algebra, we want to always do what? Bring down our problem and show our steps.
Yes.
Do you know why we do that?
Yes.
Why?
Because it's easy to get lost.
It's easy to get lost, and if you have to go back to find your error, it's easy to do.
Find it.
Excellent.
Especially if you know where you made it.
Excellent job. Okay, so now I rewrote that problem. 3 squared is 9. 3 squared, using the exponential notation, is 3 times 3. That's how I got 9. I rewrote my problem. 7 minus 6 plus 9 over 2 squared plus 1. Did you get all this so far?
Yes.
Excellent. Our 2 squared, we want to write it in not scientific, exponential notation, which is 2 times 2 equals 4. I rewrote my problem. 7 minus 6 plus 9 over 4 plus 1. Now I can solve. And when I solve, I'm thinking about Pemdas, addition and subtraction from left to right, correct? Let's go ahead and solve that. 7 minus 6 is 1. 1 plus 9 is 10. 4 plus 1 is 5. So 10 over 5 simplifies to be 2. Did you get 2?
Yeah.
Good job. Do you have any questions for me in regards to PEMDAS, which is order of operation, using parentheses and brackets, or multiplying and dividing left to right, or exponents, or doing our addition and subtraction from left to right? Do you have any questions for me on that?
No.
Okay. Earlier today, we talked about exponents, and we did a lesson on exponents. Do you have any questions for me on that?
No.
So I'm going to go ahead and do a quick review with you. I'm going to put a number on the board. So now we're going to go ahead and do the quick review based on what you learned today. Now, a lot of this stuff we learned in the 5th grade, right? But we're going a little deeper in the 6th grade, and we're going to go even further as the year goes on. So let's do that quick review. 3 to the 2nd power is an exponent, correct? Do I say 3 to the 2 power?
No.
Do I say 3 2?
No.
No. How do we say this?
You can say 3 squared.
We can say 3 squared.
Or 3 to the 2nd power.
Or 3 to the 2nd power. Now, how about if I had 3 and a little 3 on top, an exponent 3?
Then 3, that's 3 cubed.
Cubed.
Or 3 to the 3rd power.
Excellent. Very good. So when you see a 2 squared, a 3 cubed, everything else you're going to say to the power. Okay? So, in every exponent, there's 2 parts. There's 2 parts to an exponent. What are the 2 parts? Do you remember? What is the 3 called? And what is the 2 called?
The 3 is called...
The base.
The base.
The base.
And then the thing on top.
Not the thing on top. The number on top is called the exponent. Very good. Let me write that down. Very good. The 3 is called the base. The 2 is called the exponent. Now remember, what is an exponent? What do we say an exponent was? An exponent is nothing more than what? Repeated?
Repeated multiplication.
Excellent. An exponent is nothing more than repeated multiplication. So if you are doing what? Tell me what did we say today earlier about that? If you need to look in your notes, please look in your notes and read it. I'm fine with that.
About what again?
What is an exponent? We said it was repeated multiplication.
Yeah.
So when you do what? How do you know when to replace?
When you use the same factor over and over again, you could use an exponent.
Very good. When you use the same factor over and over again, you can replace it with an exponent. I'm going to write on the board the factors, right? And then you're going to explain that to me. So you just said when we use the same factor over and over again, we can replace it with an exponent, right? So in every multiplication problem, we have 2 or more factors, right? 3 is a factor, and the other 3 is a factor. And the answer, just to let you know, well, okay, you already know that. Excellent. Product. So in a multiplication problem, there are 2 parts. We have factors and we have a product. Product is the answer. Factors are the pieces of the problem to give us that answer. Make sense? Okay. So we said an exponent is nothing more than repeated multiplication. So if you're using the same factor over and over again, you replace those factors with an exponent. So our 3 is our base, which represents the factor, right? 3 is the base, which represents the factor. Is that correct, Jeremiah? Very good. And the exponent represents the number of times we have the repeated multiplication. Does that make sense? Yes. Very good. So our 2 represents the fact that we're multiplying 3 times. I'm sorry, 2 times. All right? Okay. How do I write this in exponential notation? Did I write this in exponential notation already? No. I didn't? I did. Right? It was that repeated multiplication. So exponential notation, like we said earlier, is nothing more than the repeated multiplication. And remember what we said? Think about it like expanded form in a number. When you have a general number and you're writing it in expanded form, let's say 386 as an example, right? Let me write that down. So when you have a number like 386 and we want to write it in expanded notation, what we're doing is we're writing out the place value. The 3 is in the hundreds place. That's how we have 300. The 8 is in the tens place. That's how we have 80. And the 6 is in the ones place. That's how we have 6. So expanded notation, when you're doing general math or general numbers, focuses on the place value, expanding the number in its long written form notation based on place value. But when we are talking about exponents and we're saying exponential notation, it's kind of the same thing. We are expanding the number using repeated addition. We're writing it out the long way, exponential notation, okay? So if I say evaluate, simplify this problem, how would you do that? If I say evaluate or simplify, it simply means to solve. So in algebra, when you see the word evaluate or simplify, think of solve. So if I give you this problem, 3 to the second power, and I say evaluate it, you're going to do a few things. You're going to give me the exponential notation, and then you're going to give me the actual problem. If the problem says just give me the sign, just give me the exponential notation, I don't have to solve the problem. All you care about is this piece here. Okay? All right. I hope all that made sense. So we are going to go over variables, and here are his notes from the lesson that I provided him on the board. So we are going to go over variables, and algebraic expressions, and we're going to review the distributive property, and then you're going to do some problems, and then you'll have your test. Hey, baby! Oh, hey, baby! I'm ending my video right now, so say, thanks for watching. Bye-bye. Be blessed.